All right, so I think we can get started. Hello, everyone. My name is Namikoye Lusweti. I'm a software engineer working on the Windows Protocol test suites at Microsoft. In this session, I'll walk you through the file server test suite. This is the open source interoperability testing framework many of you may be familiar with and may use to validate your SMB implementations against the protocol specifications. We've got some exciting updates, as Hagith mentioned, so let's dive in. Here's a roadmap for today. We'll start with a quick overview, what the test suites are and how they work. Then we'll move into what's new. That's a really exciting part, including some performance improvements and how we're bringing AI into the picture with the file server skills package and learn MCP. We'll wrap up with any questions you may have. And for those who've seen the overview before, I'll try my best to keep that section brief so you can spend a bit more time on the updates. So what exactly are the Windows Protocol test suites? At a high level, they are a set of interop testing tools that Microsoft publishes as open source. They allow anyone to test their protocol implementations against the same specifications that Windows uses. So what do they actually do? They act as a synthetic client, sending protocol messages directly to your server and validating the responses against the documented behavior. It's not using a real Windows client stack, so it can exercise edge cases and error paths that normal client traffic wouldn't hit. A couple of things worth calling out on this slide. They're originally developed for Microsoft's own internal testing, but they're now available for anyone to validate third-party implementations. But passing the test suite doesn't necessarily certify your implementation, but it's a strong signal of interoperability. It's not exhaustive coverage of every protocol requirement. So the test suites are fully cross-platform. You can run them from Windows, Linux, or macOS. They're built on .NET, and what I want to call out here are the two framework components in the middle row that make everything work. So the first is a protocol test framework. This is what handles the test execution, logging, configuration, and adapter management. Proto SDK sits alongside it and provides the protocol message encoding and decoding. These are the building blocks that construct and pass SMB2, FSRVP, and all the other protocol wire-level messages. At the top, you can see the protocol test manager. It provides a web-based UI for configuring and running our test cases. It's especially useful if you're just starting out, and we also provide a CLI version for automation scenarios. So this slide just shows all the entire scope of what's available. We don't just provide test suites for the file server or file sharing scenario, but the entire Windows Protocol test suites portfolio. We've got file sharing with file server covering 8 protocols, plus separate suites for SMB1, SMB Direct. Under security, we have test suites for Kerberos and AZOD. Active Directory has the AD family with 11 protocols and ADOD. Remote Desktop has both client and server test suites covering 12 RDP protocols. And bring your own device scenarios are covered by a DFS PIP. Cool. So these are the repositories we talked about, and they're what you'd want to bookmark. I'll give you a moment if you'd like to scan the QR code, but there's some short links over there as well. So aka.ms.wpts for the protocol test suites repo. In that repo is where you'll find Proto SDK, the protocol test manager, and the test suites themselves. The protocol test framework repo is the underlying execution engine, and it lives separately and is also shipped as a NuGet package. So if you want to get involved, you can star the repos and watch for release notifications. You can file issues as well, or contribute. We regularly review and merge community contributions. And of course, James and I will be here all week at the IO Lab, so come find us if you have any questions. Okay. Let's talk a bit about the scope of the file server test suites. They cover 8 protocols in total. The core protocol is SMB2, of course. That's a lot of use, bread and butter. But I want to highlight a few others that are especially relevant. So FSA covers the file system algorithm behavior, SW1 for service witness notifications used in failover cluster scenarios, FSRVP for file server remote VSS protocol used in shadow copies, RSVD for remote shared virtual disk, SQoS for storage quality of service, DFSC for distributed file system namespace referrals, and of course HVRS. On the right of the slide, you can see the SMB message types that we test. We cover the full SMB2 lifecycle from negotiate through to close, plus advanced operation like ioctl and query info or set info. It's pretty comprehensive Y-level coverage across the protocol family. Here are some of the features we test. So this matrix shows which SMB dialect introduced each feature that we test. The basics like create, read, write, and close are tested across all of the dialects, while more advanced features land where they were introduced. So for example, encryption started at 3.0, compression at 3.11, and so on. It can be a useful guide to know which dialects to add to your test cases when you're prioritizing what to validate. So we use 2 complementary testing approaches. On the left, you can see our traditional tests, which are scenario-based. They're handcrafted and deterministic that cover specific protocol requirements and edge cases. They follow a classic pattern: set up the preconditions, send a sequence of protocol messages, and validate the responses against the documented behavior. Think of them as the I know exactly what should happen here tests. While we also provide some model-based tests. They use a formal state machine models to automatically generate test sequences. They explore paths through protocol state transitions and produce test cases that cover interaction patterns you'd never think to write by hand. That's where we catch the subtle stuff. So session establishment ordering, durable handle reconnects, least break timing. So scenarios where the sequence of messages matters as much as the messages themselves. Between the 2 approaches, we have over 2,000 test cases backed by 13 protocol models. They're complementary. So the traditional give us targeted coverage of specific requirements, and the model-based give us breadth and help us find unexpected corner cases. So this is just a quick layout of how our test infrastructure actually works. On the left is the test suite, the synthetic client. So you drive a computer using the protocol adapters built on Proto SDK to send messages over whatever transport you're using, so TCP or QUIC. So this goes to your server on the right. That's your system under test. The piece I want to highlight is the SUT control adapter that's right in the middle. This is how the test suite set up preconditions on your server. So it creates shares, it sets permission, configures users, and you can implement it via PowerShell, SSH, or any managed code adapter, depending on your platform. I imagine for most of you running Samba on Linux, the SSH adapter is probably the path you'd take. We provide test cases for different environments. So this diagram shows the workgroup environment, which is the simplest and maybe standard environment. It consists of a single driver computer and a single system under test. That's your file server. It's straightforward. It's a client-server setup. And it mostly covers the core SMB2 operations like negotiate and file operations and so on. It won't test domain-specific features, but it gives you solid baseline coverage. The second environment is the domain environment. It introduces a domain controller, which unlocks the Kerberos-based authentication tests, as well as DFS namespace referrals and scenarios that depend on domain-level access control and group policies. In this setup, you have the driver computer, a domain controller, and the system under test. They're all joined to the same Active Directory domain, and it more closely resembles a real-world enterprise deployment. The third environment is the cluster environment. It's getting less and less popular. It's the most comprehensive and adds multiple server nodes and shared storage. This is where you test high availability scenarios. So like service witness protocol notifications when a node goes down, persistent handle reconnects, where a client resumes file handles on a different cluster node without losing state, as well as shadow copy operations. It's the most complex setup and essential for testing enterprise-grade file server deployments. So to recap, if you're just starting out and want to test basic scenarios, you'd ideally use the workgroup setup, then domain for more authentication-based, and then cluster for enterprise-grade deployments. So the exciting part, what's new? We shipped release 4.26.3 on GitHub, and it's a bit of a big one. I'll walk you through the headline items. So let's start with our performance improvement. We rewrote a lot of the protocol test framework. As I mentioned, it's the underlying layer that orchestrates the tests. So we added multi-threading support. Previously, everything ran sequentially, and with over 2,000 test cases, it meant long waits. So now test cases execute in parallel, each in its own execution context, with its own protocol connections, so there's no interference between threads. The numbers speak for themselves. They're on the chart. But the standout is the domain environment, which we cut a 3-hour test run on average down to about 1.5 hours. To put this in real terms, if you're running nightly builds, that's 1.5 hours of pipeline time back to you. Over a week, that's about 10.5 hours saved. So, yeah. The key engineering challenge was making the entire framework thread safe. So logging, configuration, adapters were all rewritten for parallel execution. And we're not done. These numbers will continue to improve as we continue to optimize. So some more updates on the test suites themselves. So we added some more test cases targeting changes in the SMB2 spec document between version 83 and the most recent version 85. So this included persistent handle reconnect validation and the replay eligibility flag in cluster scenarios. We also beefed up our support for SMBD. It's a bit of a big one. We now have a full Linux RDMA adapter, which means you can run the SMBD test suite directly from a Linux driver. On bug and security fixes, the notable ones are a fix for Linux SUT failures that we'd observed caused by negative output buffer length, some security patches, and package upgrades. The last three each get their own slides, so I'll cover those in detail next. So Hagith had mentioned our AI investments. So we developed a file server skills package, which is our approach to making test creation AI ready. If you'd want to develop your own test cases for scenarios not covered by ours, so we created a structured document that captures everything an AI assistant needs to know to write file server test cases. So this is the protocol patterns, the test scenarios, any configuration requirements, coding conventions, and so the workflow plays out with an engineer describing what they want to test. For example, creating a test for SMB2 create with batch oplock. So the AI assistant, in this scenario on VS Code with Copilot, as you can imagine, Microsoft, it queries the Microsoft Learn MCP server for the protocol documentation context. It then reads the skills document for the test patterns and conventions and examines the code repository for examples. It's then able to generate test code for the engineer to review and validate, the human in the loop. So the skills package itself isn't an AI. It's a domain knowledge that makes AI assistants effective at the task. It dramatically lowers the barrier for new contributors. So instead of reading through thousands of lines of code, they can collaborate with an AI assistant to scaffold new tests. Looking ahead, AI is advancing rapidly, and we're planning to go further. The next step is supporting agentic workflows with project rules and agent instructions, giving AI assistants a more structured, autonomous way to interact with the test suite. Think of it as moving from AI that helps you write a test to AI that can reason through a testing scenario end to end with the engineer guiding and approving. We're actively working on this and expect it to be a significant evolution of how test development happens. My colleague James will go into more detail about this in his session tomorrow in the IO lab. So another thing that we've started shipping is infrastructure as code deployment templates. So setting up test environments has historically been a major barrier to adoption. We're talking days of manual work potentially for people just dipping their toes into the test suites. It took some manual effort, provisioning the VMs, configuring networking, installing tools, creating shares, setting permissions, and if something goes wrong, you're potentially starting over from scratch. To solve this, we began shipping infrastructure as code templates, starting with Azure Bicep templates. They automate the entire provisioning process, and the time savings are dramatic. What potentially used to take days now takes under an hour in our testing. So a full domain environment deploys in roughly 45 minutes. And even the most complex cluster environment with multiple nodes deploys in about an hour, depending on availability and traffic, of course. Yes.
Are you happy to take a quick question?
Yes.
Okay, great. So will that deploy like Windows-based servers, or is that also adjustable to deploy like Linux systems?
Yeah, it's adjustable. So we provide some parameter files where you can target specific builds. You can target like custom images, for example. Yeah, so yeah. So each deployment is fully independent. So you can spin up multiple environments in parallel without conflicts. And because it's infrastructure as code, the setup is error-free. So no more typos in configuration files, no missteps, and no, it worked last time, but not today. So here's where it compounds. If you combine these templates with the multi-threading improvements from earlier, the total time from I want to test to I have results drops from days to a couple of hours. It's exciting. So another thing we've started doing is releasing protocol document diffs designed to help you understand what's changed between the version of the protocol you last implemented and the version you're looking to adopt now. It addresses a common pain point we've had from partners where protocol specifications get updated quite regularly, but figuring out what's changed since the version you last implemented is a bit difficult. So you'd have to review entire documents across multiple versions at worst. With these new release comparison resources, we highlight the protocol requirements that have changed between releases, allowing you to quickly see what may impact your implementation when planning upgrades or validating compatibility, or even deciding whether any new or modified requirements need to be incorporated into your implementation. So how this is shipped, in our release on GitHub, there's a zipped folder with comparisons between version 85, which is the most recent spec, and 84. So 85 against 83, against 82, against 81, all the way down to the last document that we have access to. So if your latest implementation targeted version 81, you'd be able to get a list of all the code changes that have happened between version 81 and 85. So that's pretty nifty. It's a new feature, and we'd genuinely love your feedback on it, whether the format works for you, and what would make it more useful, so you can let us know. That's all I had. I'll open it up to any questions you may have.